to do the opposite to what we did in this question. So this is the previous one that we had worked on, where we're going to take a value in from the user. We count from the number 1 up to whatever the value the user enters in, and we're only going to print out the odd numbers. And then we're going to stop once we hit whatever the limit is. So let me go and save this as it's 5. And it's 5. So we're going to do basically the same thing. We don't really need to worry about that. We can leave them as they are. We can leave this as it is. I do need to change what's inside here. So this is going to become while input, lowercase I, is less than or equal to counter. So again, we're starting with the larger number. We're working our way down to the smaller number. We want to print out the even numbers. So we're going to say while it is equal to 0, we want to print it out. The printout statement is going to stay the same. And the last thing we want to change is that we change this to a minus minus. So we're decrementing the value each time. We're reducing it down toward our endpoint, which will be counter, which is not a great name. So actually, let me change the variable name here. Let's call it something really obvious, endpoint. Actually, we need to print out input, not counter. Spell it correctly, input. Okay, so what we have here, and then that should be input, reduced. So let me go through that again since I've rejigged some of the variable names. We have our variables up here. We have our input, which is going to be for our user input. We have our endpoint. I'm not going to write a comment there because that should be a sensible enough variable name. You know what it's going to do. I'm going to ask the user to enter a number. They're going to enter in that number. And my loop is going to keep going while the current value of input is greater than or equal to endpoint. So if I put in 10, it'll go 10 all the way down to 1. As long as it's greater than or equal to 1, we're fine. As soon as it drops below that, well, then that's where the issue arises. Inside, very much like the previous question, we're going to evaluate if the current value of input is an even number. Well, then we'll print it out. If it isn't, well, then we skip this entirely. And in both cases, we're going to reduce our value of input down by 1, moving it toward our endpoint. So let's test that. So we enter a number, let's enter in 34. And you can see there the output is 34, 32, 30, 28, and so on, all the way down to the number 2. That doesn't print out the number 1, doesn't print out the number 0, because number 1 was our endpoint. That was really the last possible number that we could do in our loop, but 1 is an odd number, so we wouldn't be printing that out anyway. So if I take that code, and if I open up the previous example, loops 4, and move that to the other view. Now I need to shrink it down a little bit for this to work. Okay, so what we can see here, we have them side by side, is that they're very similar. We have different variable names, that's fine, but we can see that, well, in this example here on this side here, this is our counting down loop. So we start with the input, that's the higher number, and we're working our way down to our endpoint. Here we have our counter, and we're working our way up to whatever the user said is the endpoint or the input. We have an evaluation inside each. That's counter if it's an odd number, or input if it's an even number. And if we're allowed in there, we're going to print out the relevant value. And in both scenarios, then we're going to alter the changeable part of our loop. We're going to move towards the end point. Remember, our loops need three elements. They need a starting point, they need an end point, and they need some element of progression, a way of moving towards that final iteration of the loop where eventually our line 12, the Boolean guard here, the round brackets, will be invalid. We will no longer be allowed inside that loop, which means it kicks us out of it and it moves us down to whatever the rest of the program might be. So seeing the two of them side by side, do you guys have any questions for me on those questions?
Just scroll up on that.
Yep, I'm going to throw this all up into the OneDrive anyway, so don't worry too much about it. If I'm going to give you another question to do, everything I've done so far will be put up in the OneDrive just to make sure that it's all there. Any other questions? Everyone's reasonably happy? Okay. Let me get rid of the questions I've done here. Okay. So the next example I want you to do. Let me close that one down here. File, save as. 6. This is here. Great. Program that makes a number of the user. One, 2, 100. Set for the user. Okay, so that's the question I want you to have a look at now. Let me quickly just throw the other stuff up onto the OneDrive. So let's loops this. Get rid of it there. Okay, so I'm going to leave loop 6 up there as well, but that's just so that you can have a written version of this example here. But that's what I want you to do. Based on the values that I've given you, I want you, or the programs I've given you so far, I want a loop that's going to ask for a number from the user, so obviously a number between 1 and 100, and it's going to print every number between 1 and 100 except for the number the user enters in. So if they enter in 25, it'll print out the other 99 numbers in that list. I don't care whether you count up or you count down in that loop. It doesn't make a difference. The key thing is that we shouldn't be able to find the number the user's entered in the output of the list. So I'll give you maybe 10 minutes to have a look at that and see how we get through it, and then we'll work through a solution of it. Yep.
It's only printing the one number and I honestly can't see why.
Okay. Because you're checking the end point is an even number rather than an input.
Okay. Okay.
That's why it's probably the end number is printed out the one you entered in to begin with.
Okay. That makes sense.
Yes. Okay, so if you that right there, we really do share. So when you're doing not equals, you'll get 1 equals, right? So that's one exclamation point and 1 equals. Whereas when you're doing equals, you just have 2 equals. Does that make sense? Yeah. When you're testing this one, don't enter in a ridiculously large range number. Stick with for testing, stick with 1 to 20 and enter in a number that's between there to not print it out, so it's very easy to see what it is. And then once you can verify that, you can increase it from 1 to 100.
It's okay, that's great. People know the machine already.
Maybe another 2 minutes, 3 minutes, and then we'll. Okay, let's have a solution for this. Let's have a look at this one here. So we're going to need to create our program. It's going to take in one value from the user. It's going to print from 1 to 100, and it's going to skip over the user's value. So we can leave this here. We can leave the user input. We will have a variable called counter, and we'll set that equal to 1. We're going to ask the user to enter in a number. We're going to go from counter is less than or equal to, let's go with 100 here. We're going to have our if statement, and then we're going to have counter plus plus. And if we're allowed into the if statement, we're going to print out all the values. So the key thing, the only thing we have to change now is that. The rest of the code is pretty much done. It's a nice small little program. So declare our user input, declare our counter, that's fine. We've done that in previous examples. Take user input in, we've done that before as well. Have a loop that counts from a number up to another number. We have done examples of that. Increment that number each time so that we're going up. That's great, we've done that. Print out a number if you're allowed. We've done that. All we need to add in now is the check to see if we're allowed. So we want to print out every number except for the number that the user enters in. So what I'll do here is I'll say as long as counter is not equal to input, well then we're allowed to print it out. If counter is equal to input, we skip line 17, so we missed the print statement. It increments to the next number, and it goes forward as per usual. And so at the next number, we've changed. Counter is now a different number, so it can't be equal to the previous one where it was equal to input. And so it'll print it out again, and go around, and go around, and go around. Does that make sense? Okay.
But you said, for example, for the 25, you can put any number?
Oh, so if it's 25, I'll just do 25 there.
Okay.
Yeah, so this is just the upper range. Let's do a 25 to begin with to test it, and then we'll increase it. That's actually a really good point. A lot of the times I'll give you a problem where I'll go like 1 to 100. Or in the guessing game, allow them to enter in 20 incorrect guesses before you kick them out. That's the final version of the program. But you can absolutely alter that code when you're testing it to reduce down how many values you're doing. Me personally, if I was doing the guessing game question, I would test what happens if they get 5 incorrect guesses. Do you kick them out? And once it works with 5, you can change that number up to whatever you want it to be. If you really wanted to get fancy with that question, you could build in difficulty levels. If they select easy, they've got 20 goes. If they select medium, they've got 10 goes. If they select hard, they've only got 5 attempts. You could absolutely do that, and you have the skills to do that at this point. But I'm only asking for them to attempt 20 times. But what I'm getting at here is this is 1 to 100. That's a lot of numbers. But for testing purposes, I'm going to do 1 to 25. That's easier to see. And then when I know that works, I'll increase it up to whatever value it needs to be. So S there. Let's go into our command line. And we're going to go Java C. Oops. 6. No. 6. And then Java loops 6. So it's going to ask to enter a number. I'm going to enter in 24 because I know which end of that line that will be. So I'll enter in 24. And you can see here, come over. It's got all the numbers, and then we get 22, 23, skips 24, it prints out 25. Okay, so now that I've got that working for the first 25 numbers, it's a trivial change for me to go in and change this to 100. Save it again, build it again, run it again, and I'm going to enter in 33. That'll print out all of the numbers, but when we get to 33, you can see here that it's missing from the range that we're looking for. Okay? Think about what that loop is. I've added in noise into that question. I've added in stuff that isn't necessarily relevant to a loop. You might look at that question and look at the way I coded it and go, oh, that's a very complicated loop. It's not. The loop is incredibly simple. The loop is line 15 and line 19. Count from this number up to this number. That's it. That's all it is. What makes it seem complicated is the evaluation, the question we ask inside the loop. And if I just gave you the question on its own, so tell me if I've entered in the same number. That's your guess. That's essentially your guessing game question. Does the number the user's entered in equal the number I'm trying to guess? So if you just took the guessing game question where they get one attempt and it's just an if statement, create a variable with a number they're trying to guess, take a user input in. If the two numbers are the same, print out, you win. If they're not, print out, you lose. That is an incredibly easy program because you're just checking is number one equal to number two. Do this. Otherwise, print out, you lose. All I have done is I've put a loop around it. So it's going to do that repeatedly to a whole range of numbers. That's it. And that's a really important trick when you're looking at these questions. When you get 3 lines of text describing the program you have to build. Chop it up into small parts. What do I need to do? I need to print out every number from 1 to 100. That's great. I need to take in user input. That's great. I need to print out all of the numbers except for the user input. So I need to have an if statement to check. Have I got to the number I don't print yet? And if you split it up into little blocks, the program all of a sudden becomes much easier to deal with because you don't need to worry about, that's huge, how do I do all of that? You go, oh, that's the first part. I can do user input, no problem. That's a counting loop from 1 to 100. I can do that, no problem. The only difference between this and the very first question I did with you, where we sum up all the numbers, is we're doing something different inside the loop. It's still a counting loop. It starts at one end and it rolls up to the other one. And what we've changed is inside, we have different work for that loop to do. Rather than saying, take the current value of sum and the current value of counter, add them together, set that as the new value of sum, increase the value of counter, which was the very first question we did. I have some work here. Ask if the current value of counter is equal to the user input. If it is, is the current value of counter not equal to the user input? If it's not equal, print out that value. Increase the value. Check again. And repeat that over and over and over again. And then if I wanted to say, the first 10,000 numbers, 100,000, 1 million, 10 million, that's irrelevant. The value here, how big that number is, shouldn't be scaring you off. In an exam paper, in the exam you'll take in May, the 3 hours handwritten pen and paper exams, you can't automate it. You can't copy and paste code because you're handwriting the stuff. I will very often use ridiculously large numbers. Calculate all the prime numbers in the first 17,000 numbers. There's 2 reasons why I do that. One, the most important reason, is to catch out people who don't understand what I'm asking. Because there are some people who will, if I ask you calculate all the prime numbers between 1 and 100, they will sit down with a piece of paper and they will work them all out, and then they'll just have a printout statement. Print out 1, print out 2, print out 3, print out 5, print out 7, print out 11, print out, and so on, so on, so on. But I don't want that. I want you to get the computer to do the work. If you're doing the computer's work, you've done it wrong. The whole point of this course of learning how to program is to get the computer to do work for you. So picking 17,000 as my range of numbers, you would spend, let's ignore how long it would take you to write out all of those statements, which is probably the full 3 hours in itself. To calculate is 16,997 a prime number or not. Would take 10, 15 minutes to actually do all the calculations. And if you have to do that for 17,000 numbers, you can't rote learn that. You have to think of a way to programmatically solve that problem. And that's what I want from you. That's what I want out of first years. I don't really care if you know all of the extra commands and you're really good at Java. Java is irrelevant in this scenario. It's a means to an end. What I want you to do, programming is actually a means to an end. What I want you to be able to do is look at a problem and go, okay, never done that problem before, but I can see 1 part, 2 parts, 3 parts, 4 parts, 5 parts. That middle part, part 3, that's going to be big. That might actually be 2 or 3 parts itself. I don't know how to do part 3, but I definitely know how to do part 1, user input. I know how to do part 5, printing out a value. It needs a loop in there, so I know how to write that. I have to ask a question. I need to check, is this value matching what it should be? So I know how to write an if statement. So of the 5 parts I've immediately identified, I can do 3 to 4. So the part I can't do, or I don't know how to do, that's my challenge. And you fill in the gaps. It's like doing a jigsaw. You start with the bits you can do immediately. Get the corners, get the edges, work your way into the center. Nobody starts a jigsaw from the centerpiece outward. That's impossible. Okay? What you want to do is you want to do it the easy way. It's not impossible, it's just it's counterproductive. It's a lot of extra work when you can start at the corners, which you have only 4 of them. And then you get all the edge pieces and you only have a finite number of them. And then what you're doing is you're reducing the empty gaps, the bits you don't know how to do. And that's what I want you guys to be able to do with the project or with the programming you're doing this year. Okay, next question to do. And I'll go through this one, and then the last one I'm going to give you will be, I'll give you 2 more after this. Okay, so the next one we're going to do is we're going to create another counting loop. All of our loops so far have just been counting loops. 1, 2, 3, 4, moving along. This is going to also be a counting loop. It's going to count from 1 to 100, but we're going to get the user to decide how big an increment it is. Does it go 1, 2, 3, 4, 5, 6? Does it go 1, 5, 10, 15, 20? Does it go 1, 33, 66, 99? We get the user, we're going to let the user decide how big of a jump it's going to be each time. Okay? So, let's save that. Actually, no. Let's put it back to 100 and save it there. Let's go File, Save As, 7. Okay, up here. So this question, create a program that takes a number from the user. And prints every number from 1 to 100 in increments of the user input. Okay? So if they enter in 3, we're going to jump up in 3s. If they enter in 5, we'll jump up in 5s. Okay? So it's still a counting program. It still requires user input. It still requires an element of printing. What we need to change is, rather than going plus plus, which is just up by 1, we're now going to go up by however much the user defines each time. Or at the beginning, sorry. So we have our user input here. That's good. We have our counter here. That can all stay the same. This can stay the same. We'll take the value in. This can stay the same. If I go back up and read the question, fix my spelling. There's no condition in this. I'm going to print a number. I don't need to evaluate whether I will or will not print that number. I'm always going to print a number. So I can remove the if statement. I don't need an if statement in this. Okay. So that is going to be the same. I've removed the if statement. And the line that I do need to change is this one. Because counter plus plus just brings me up by 1 each time. But what I really want to say is going to be counter to be equal to counter plus input. So whatever the user enters in, if they enter in 5, it's going to go, I did actually say 1, 5, 10. I won't do that. It'll go 1, 6, 11, 16. Okay? So it's going to increase my counter starting at 1 by however many values the user enters in. Or what size of variable the user enters in.
So if they,
Sorry, if you change the 1 to 0, would it go from 5 to 10?
It would go 0 and then 5, 10, 15, yeah. It's just where the starting point is. It's going to add 5 onto the starting point. So 1 plus 5 will be 6, and then 6 plus 5 will be 11, and then so on. So the question you had?
What, I think it was almost the same question, but I want to know the, what is up, it's 0.
Yeah, so input that starts at 0. That's, as I said at the very beginning of the first example I did that was from the slides, I don't need to set it to a starting value because I'm going to take in user input here before I ever use it. But I kind of like to do that. I like it. It's a habit I've built up. It doesn't affect your code anyway. If you forget that and you just do that, that'll still work. That's fine. But I have a habit of if I declare a variable, I always give it some sort of a starting value just to ensure that I always have a starting value for every variable.
It's just the default, like, is it?
It's when you create a variable, you need to declare and initialize it. So you need to declare it by saying, hey, this is going to be an integer variable and I want to call it input. So it'll go off to memory, it'll carve out the 4 bytes it needs for that integer. It remembers where that is in your RAM on the machine, and every time you call the word input, it goes, oh, I'm going to be going over here. But the initialization is also putting in your starting value. So it's not a default value, but it's your start point. And if that changes immediately, as it does here, that's absolutely fine. There's nothing wrong with setting it at 0 and then immediately changing it. There's also nothing wrong with doing that. The reason why I don't encourage that with first years is because if you forget that here, because you want to take in user input, what if you forget it there? Then it actually causes you a problem. So if you always set a starting value to every variable, even if you're going to immediately change that value here, it means that you don't forget to initialize the variable you should initialize because you're not going to take user input. Okay.
So if we start adding like 5, it will depend of the first number you enter.
Yeah, so I only take in one number, so it's going to depend entirely on this.
Yeah,
Okay, so if I run this so you can see what it looks like. Can I save that? I have. Okay, so Java C, oops, 7. Java, oops, 7. Okay, it's going to ask me to enter a number. I'm going to enter the number 3. So it's going to go up in increments of 3. It'll go 3, 4, 7, and so on. So you can see there that will be roughly 33 numbers it prints out, and it's going up in increments of 3. And if we had started at 0, then it would be 0, 3, 6, 9, and so on. If I ran it again, and let's say I enter in 1, that's absolutely fine too. It prints out every number because it's going up in increments of 1. If I ran it again in numbers of 13, it would print out far less because when you go up in increments of 13, you're skipping a whole load of numbers. Does that make sense? Okay.
now I get it.
Good. Well, that's great. See ya. That's enough. That's good. If it makes sense now, that's fantastic. Okay. I'm going to give you another question to work on. It's kind of related to the last question I did. So I'm going to save these questions and upload those to the OneDrive so you have all those for reference points. What I want you to do is I want you to create a loop that keeps going until they enter in a specific number. So let's pick a number. Let's pick the number 13. The loop will keep asking you for a number until they enter in the number 13. Okay? So if you're unsure of what to do, the code isn't in your slides. However, if you look at the last slide in the loops, this example here, that's the structure we want to deal with. We're going to, inside the loop, we're going to prompt the user, hey, please enter in a number. We're going to read in the number. We're going to decide, are we quitting now or not? If we're not quitting, then we're going to ask them, we don't need to display the square in R1. We're not doing that part. We're just going to ask them another number. So you keep asking it over and over and over again until they enter in the number 13. Okay? So let me quickly save off the stuff. And then you can... There. So across there. And C, E, 2, space. Okay, program that takes in number from the user. So, create a program that keeps taking a number from the user until they enter number 13. Okay. So loop 7 is available on the OneDrive now, and you should be able to work from there.
Okay, let's look at this one.
So in this example here, I need to take a number in from the user, check to see if it's equal to 13. If it's not equal to 13, we're going to ask the user to enter it in again, and that's the loop will go around and around and around. In this example here, we don't need a counter variable. We can say, please enter 13, taking the value there. We actually can restructure this loop a little bit, right? And this is why, again, it's nice to set your input variable to 0, even if you're going to immediately use it here, because what we can do is we can say, take this loop, put it up here, and say while input is not equal to 13, we're going to prompt the user to enter a value. And we'll go around again. And so what will happen now is, let's put output here. Sorry. Okay, so we're going to set up our scanner and set up our input variable. We're going to have a loop that says while the value of input is not equal to 13. So our starting value is 0. We all agree 0 is not equal to 13. So we're allowed into the loop. We ask them to enter the number 13. we let them take in a value, and we go around again. And if they don't enter in the number 13, we're going to ask them to enter the number 13 again. We're going to take in a value, and we keep doing that until they enter the number 13. And when they enter the number 13, then we're going to say thank you. That extra space this one. So it's a pretty small question. So let me test it first of all, and then I'll verify questions. CS, C, oops, 8. Java. Java. Oops. 8. So enter the number 13, 2. Enter the number 13, 56. Enter the number 13, minus 13. Enter the number 13, 2. Doesn't matter what you enter. This will keep going for as long as you want. Doesn't really matter. And then when you enter the number 13, it says thank you, and it quits out. So what's happening in this loop is that we start off with our starting value for our input on line number 9 as 0. We don't take our user input yet. You could absolutely have these 2 lines of text copied and duplicated on line 10. That's absolutely valid. So you could take in the value first and then check should you go into the loop or not. And then you still, inside the loop, have the question where you ask them for the number, you take in the number, and then you reevaluate it. So that's one way of solving that problem. Another way of solving that problem is that you change the loop to match something that we had in the slides, where you set this equal to true, so the loop always goes in. But after you take in the value, so after line number 13 of the code, you have an if statement. If input is equal to 13, break, and that will quit out of your loop. So let me show you what the other part of that code is going to look like. Same as 8A. So what this would look like here is that you would have just the word true here, which means you will always go into the loop. You are going to ask them to enter a number. You're going to take that number from the user. When you take the number in, you're going to say if input is equal to 13, then we are going to use the keyword break, which will quit our current loop. It works basically the same way. There's no evaluation to be done there. Remember, our Boolean statement needs to simplify to either true or false. If we use the literal value true, it means that the loop will always allow us in. And then if we always are allowed in, we need to write code to decide, no, that's it. We've done enough now. We can quit out of this loop. So that's another way you could do that. Save that. Save as. Another way would be to have these 2 lines of code here above. So you're going to prompt the user before the loop starts. The loop, you're going to check to see if input is not equal to 13. And then once they go into the loop, that loop keeps going around and around until you quit it out. That's also a very valid way of doing it. You ask for the number the first time round, that checks to see if we even ever go into the loop. And if we don't go into the loop, let's say they enter 13 the first time, it skips the loop entirely and it jumps down to line 18 and says, thank you. But if they enter a different number first, then you keep prompting them until they enter in the correct value. And then eventually you'll say thank you when they enter the right. So that is the same question solved 3 different ways. They are all as valid a solution as each other. They're just different ways of approaching the problem. Whenever I show a sample solution, that is all it is. It is a sample. It is one way of solving that problem. There are multiple ways of solving it. So as you're doing your worksheet now, when we come back after the assignment week, as you are looking at the take-home assignment, the larger assignment I'm going to end up giving you, don't be worried if it doesn't, the way you solve the problem doesn't match exactly to what we want or the way I cover the code. If you get it working, it does the job it's meant to do, but you've written your code slightly differently. You put extra readouts here rather than inside here, or you had true here and you use the break statement. If it does the job, if it achieves the task I've set it to you, that's what I'm looking for. Now, if usually what happens when I give it an assignment is as soon as the deadline has gone and it's accepted back up, so before I've corrected it, I will go through a sample solution. If my sample solution is, let's say, 200 lines of code, and you've submitted me a 7,000 line program, it still works. Maybe it's not the most efficient way of solving it. So in that type of scenario, you lose marks for a lot of repetition or redundancy in your code. It doesn't mean that you'd, more than likely, if it does the job it's meant to do, and you just have written huge amounts of code to get that done, you're still going to pass. You just won't get a very high mark. If you have code which is somewhat in line with what I was looking for, you're going to end up getting the higher marks. If you're missing functionality, so if you don't do some of the parts I've asked you to do, well, I can't give you marks for them. If you attempt them and they're not working, but you've commented them out, I can give you attempt marks. If you do something completely different, I usually only leave somewhere between 5 to 10% of extra credit in each assignment to allow for extra things. So, for example, the difficulty level in a guessing game. So you've done the assignment and you said, oh, this would be interesting, I'll attempt this. I usually leave somewhere between 5 to 10% for that. So you have 90% where you've really clearly defined I need to do X, Y, Z. And then you have 5 to 10%, whereas if you want to put in the extra effort, you can do it there. The students who don't put in the extra effort anyway, who are just aiming for the pass, that's kind of irrelevant to them. But the students who have done a lot and want to push it to see how high a grade they can get, that's usually where they kind of thing. Okay. Does anyone have any questions on what I have done so far? So if you think about the questions that we have done in the last 7 weeks, either on your worksheet or in labs or in examples I've done on the board, we have looked at a couple of loops tonight which makes them more robust. So think about, one that we haven't done is think about the days of the week question. Enter in a day number and you print out Monday or Tuesday or whatever day it might be. And if you enter in something outside of the 1 to 7, you'll say, that's not a valid day of the week. And then the program finishes. But we've almost got to the point where we could say, put all that in a loop. And if they don't enter in a number between 1 and 7, get them to enter another number. It's kind of taking this question here and expanding it slightly. So you're looking at not just one. The one thing I will say about the loops we've done tonight, the guards in them have all been very simple. They're one condition. I'm just checking one number. Is it equal to this? Is it not equal to this? Is it greater than this? Is it less than this? But remember that we can take this and we can use a logical and put more statements in there. So we could say it's not equal to 13 and it needs the modulus of 2 needs to be equal to 1. So it needs to be an odd number. We can also use a logical or using the pipe symbols and we can type something in there. So the statements we've used so far in both our if statements and in our loops have been pretty simple. They've been single conditions. But we can combine these. If you think about your legitimate date question on your workbook, you can write 12 plus 1, somewhere around 20 if statements. I say, well, if the month is equal to 1, and if the days are between 1 and whatever. Or actually, if you weren't doing any combining, you say, if the month is equal to 1, and the days are greater than 1, and if the days are less than 31, well then it's a valid date. If the month's equal to 2, and the days are greater than 1, the days are less than 28, well then it's a valid date. So you could build up that. But by using, because if you think about remember the nursery rhyme we all learned, 30 days has September, April, June, and November? So you think about that, you could combine all that. You could say, if the month is equal to September, so that's 9, or 4 for April, or 6 for June. I forgot what you're right. September, April, June, and November, or 11 for November. Well, then you could use, if the month is equal to 9 or 4 or 6 or 11, then you know that the range for the days has to be somewhere between 1 and 30. If it's equal to 2, well, then the range has to be between 1 and 28. We'll ignore leap years for a second. Every other month has to be between 1 and 31. So you're simplifying, you're making the statement inside the brackets here a little bit more complex, but you're reducing the footprint of your code, how many lines of code you have. You're making this slightly more efficient. Okay, so it's worth thinking about those when you look at the problems. You've in computer hardware, you've looked at logical gates. You've looked at truth tables at this point, so you know how an AND gate works and how an OR gate works. And in programming, they work exactly the same way. If I have an AND gate, for the statement to be true, both sides need to be true. If I have an OR gate, one of the sides needs to be true, and then the entire statement is true. And we can combine them, and we can build up quite complex things. So let's do our last question, and I'll run through this, and then we'll leave the remainder of the time either to leave it a bit early or to ask any questions if you have questions. Let's do the days of the week question. Okay? But let's take the days of the week and a loop to make sure that we're going to keep asking until they enter in somewhere between 1 and 7. And once they've done that, we'll print out the day and we'll quit out of the loop. So to do this, I'm going to need to, let me save that. Oh, let's not save that. Let's do that. Save it there. Open up my OneDrive. Last week was loops. Okay, so not that one there. Before that was if statements. Now, I can't remember which one, so let's quickly go through it. It's not that one there. Not that one. Not that one. There we are. Okay, right. So save this as a desktop. Loops 9.java. Loops 9. So this code, this is the code that I've already done. It's already up in the OneDrive. It was conditionals 3, I think. So I have the asking the question once done. See, there I have all the statements. And if I have an invalid entry, well then I'm going to need to get them to do it again. So I need to put a loop around all of this. We're going to take in our value first. We're then going to go into a, actually, let's think about the structure. We don't necessarily need to have this part here that I've highlighted in the loop. Because when we get to the point where they've entered in 1 through 7, a valid number for the day of the week, it'll print out the day and then we're done. That's it, the program's finished. It's only when they don't enter in a valid number that we need to have the loop. So what we can do is we can have our statement here. And we can say while x, let's leave that there for a moment. We'll come back to that. And we'll say inside here, take in the number to begin with. If they don't enter it incorrectly, we're going to ask them to enter the number again, but we're also going to prompt them to say, by the way, that was an invalid entry. So they know why they have to enter another entry. So our loop is going to stop them progressing any further in our program. We're going to enter in the number the first time around. If they enter in a number that's between 1 and 7, great. We skip this whole thing that's highlighted there, the loops, and we just move on to the selection of which day we're going to print out. But if the number is higher than the number 7 or lower than the number 1, we're going to keep asking them to enter a number until eventually they enter in the correct one. So what goes inside the bracket here is exactly what I just said. If the number is lower than number 1 or higher than number 7, so if it's 0 or 8 going outward, that's where we're going to ask them to enter the number again. So here, what we're going to say is if x is less than 1, or, because x can't be, and it has to be or, because x can't be two different numbers at the same time. So it can be one or the other. It can't possibly be both at the same time. So that's how you know where you use an or an and. If x is greater than 7. So if either of those conditions happen, and that should be a lowercase x, not an uppercase x. If either of those conditions happen there, it's going to say, well, that's not a valid entry. Please enter in the number for the day of the week, 1 through 7. And they're going to take the value in again. It goes back up and it checks. So if they've entered in 1, this part here will be false. And this part here will be false. Okay, because 1 is not less than 1, and 1 is not greater than 7, which means the whole statement is false. We're not allowed back in here to move on line 18 down, the bits of the code we've already done. However, if they enter in minus 200, well, minus 200 is less than 1. And if you remember that from computer hardware, when you have an or, true or anything is automatically true. We don't need to even check the right-hand side. We automatically know there's going to be a true statement. So we immediately bring them in, tell them it's an invalid entry, ask them for another number, take in that number, and check it again. Does anyone have any questions on that loop before I test it? Or do you want to wait and see how it works before you ask questions?
So the sign is like
These two lines here?
Yeah.
Yep, that's called the pipe symbol. To type that, it is on my keyboard. It is hold down Shift and the backslash key. But it might differ depending on if you're using a non-QWERTY UK keyboard.
You need to put an equals where the 1 is as well for 1 to actually work.
No, because so the valid numbers in my program are 1, 2, 3, 4, 5, 6, 7. I want to deal with the other 2.4 or the 4.8 billion possible options the user might enter in.
Oh, sorry, yeah.
So that's why if it's less than 1 or if it's larger than 7, so if it's 0 or 8 heading outward. Any other questions? Does that make sense to everybody?
I just don't know down at the bottom, did you delete the last else?
I did, and good observation. The reason why I deleted the last else is if they've entered in an invalid entry, they will never get past this loop. So it became redundant. It was a piece of code that never would be reached, because if they entered in a number that wasn't 1 through 7, they wouldn't get past this part here. That's the amendment I had to make. In the previous question, when I got rid of the last else, you let them enter in any number, and if they enter in 1 through 7, you print it at the appropriate day of the week. Otherwise, it said invalid entry. Program finished. This will keep going until they enter a right one. Okay? Let's run it and see what it looks like. I beg your pardon?
Yeah, that's
you add this.
I added S. Fantastic. Not intentional at all. CS. No, CLS. Java C. Loops. 9. Okay. Enter a number for the day of the week. If we enter into Great Prince Tuesday. Works the same way it usually did. But if I enter in now 9, it'll tell me that's wrong. If I enter in 11, it'll tell me that's wrong. If I enter in -1, it'll tell me that's wrong. If I enter in minus whatever that is, wrong. If I enter in 5, it tells me it's Friday. Okay? So in the logic of this program, I'm going to shrink it down just a little bit so you can see what's happening here. We declare our variables. We take our first user input. And here is your stalling point. Here is where the program will not progress any further until the user enters in an appropriate value. And once they enter in an appropriate value, well, then it makes this part here false. So they don't get to run any of the loop. and we start on line 18, and then we go down to our ifs and work out, well, which one of these is a match. It guarantees, the way I've written this, that it has to match at least one of these. Well, it will only match one of them. It can't match any more than one at any one time. So we just go down through it and see which one it is and what do we print out. Does that make sense? Okay. So that's the end of loops. We are halfway through the semester, a quarter of the way through the year. As I've kept saying over the last couple of weeks, you have now covered the 5 important elements for programming, and that everything that we do beyond this is applying those 5 elements to either different data types, like strings, which is the first thing we look at when we come back, or different locations of information, like text files or like arrays. But we don't really do anything new. What we do for the remaining 3 quarters of the semester is apply those 5 elements in different combinations to make our programs increasingly complex. And that gives us the practice to solve more difficult problems and to look at. It gives us the practice and, I suppose, the exposure on problems so that you can go up and you can see a question like that. And you can go, oh, I can see roughly there are 5 parts or 10 parts or 15 parts or 2 parts. And of all the parts that I can see that are there, I know how to do this many of them. And if you're really lucky, you'll know how to do all of them. And it's a matter of just assembling it. But more than likely, the way I had structured the course, you won't know how to do all of them immediately. And so you'll have to fill in the bits you know how to do first and reduce down what the unknown section of the program is. And that's what your challenge is for each of the questions as we go forward. There's notes for the remaining 2 quarters. We're not finished with the notes now. I've given you the fundamental elements, and we're just going to apply them in different ways going forward. It's really important that you understand these 5 elements. I would like if over the assignment week, because I'm not going to have a class next week, that you just kind of think about, well, what are you comfortable with and what are you not comfortable with? If I know what you're not comfortable with, I can focus more on the examples I do to give you more exposure, to give you more practice. If everybody's comfortable with everything, well, one is at least as lying, because statistically, no one, over the last 9 years of me teaching this, I have never got to this point in the year where everyone's like, oh yeah, no, we're perfect with everything. You might think you are, but then just make sure that you've got all of your worksheet done. Because if you are perfect, if you're fine with all the elements we've covered, you should be able to do all the questions in the worksheet right now. And you've got another 19 days or so to work on it. So it's a matter of just finding the time to sit down and write the code. If you're not 100% in it, it will mean that at least one of the questions in the worksheet, it's going to be difficult for you to accomplish right now. So if I know that you have a challenge in, let's say, loops or in if statements or just in that part there, what do we put inside those brackets to make sure it evaluates as true or false? Well, then I can do examples and I can do focus on that to get you up to speed, to get you comfortable with that. If you're comfortable, but it requires you to go back and look over notes and look over other examples, but you're piecing things together, that's absolutely fine. You just need more practice, and I will give you plenty of practice. So just over the next week, just figure out where you sit. If you're happy, fantastic. If you're not happy with everything, if there's bits you're shaky on, let me know. You can do that via email. You don't need to put your hand up and go, I don't know loops, I don't understand that. That's fine, I'm not going to ask you to do that. But it means that I can focus when I'm going to teach it, or the examples I use. We're still covering new topics. I'll just make sure that we're also repeating and revising bits, which might be 100% in the class. Fair enough? That's us for today. Thank you very much. Safe home, because as you can hear, it's like a war zone outside. If you have any questions over the assignment week,